So you do need a calculator. You don't so much need to copy down the words today. I do. You should have this in your notes. This is actually really good. I got this from the Berkeley statistics program. I thought it was well worded. I liked it. And so it just lends some context to the last or one of the sections you're doing today. As we're copying down notes today, you don't necessarily need to copy down all of the words, so to speak. Rather, the tables and the math, right, are what are important. So not too bad. So we are calculating probabilities today. And the first one I love. This is my favorite kind of probability question. So example 1. A bag contains 3 red, and again, you don't have to write down all the words, abbreviate, 3 red, 5 blue, and 4 green marbles. And so they're all in a bag. If 3 marbles are drawn out, we want to find the probability that all 3 marbles are blue. So we want to know the probability of 3 blues. And so really you can, what's circled and what's underlined. If 3 marbles are drawn out, we want to know the probability of getting 3 blues. This is the kind of probability question I like because we can actually just apply the counting principle really easily. And so this is kind of an interesting thing. When you reach into a bag, and would you draw out all 3 at the same time, or would you draw one at a time? One at a time. And technically it doesn't matter. But we're going to say that we are going to draw 3 times from this bag. Now, but whether or not we draw them one at a time or all 3 at a time, are we putting the marbles back in? Or are we just taking them out? We're just drawing them out, aren't we? Okay, so that's really important. And we are just drawing these marbles out of the bag. And so we want to know, if I reach into the bag, first of all, how many marbles are in the bag? 12 marbles. How did we get 12? Added together. 4 plus 5 is 9, plus 3 is 12. Okay. So there are 12 marbles in the bag. And so if I reach into the bag, what's the probability that I'm going to draw out 1 blue marble? Remember, probability is successes over total. 5 out of 12. Very good. There are 5 blues in the bag. So there are 5 successful blues to choose from. And there are 12 marbles in the bag. All right, I took that marble out. Ladies and gentlemen, how many marbles are in the bag? 11. Oh. Now there are only 11 marbles in the bag. Oh, wait, and if I got a blue, then how many blues are there to choose from? What? Only 4 now. That's right. Now there are only 4 blues. Okay, and I drew out another one. Let's pretend. And so how many marbles are in the bag? 10. All right. And now how many blues are left? Just 3 successes to choose from. I love this, ladies and gentlemen. Would you call these drawing these marbles out of the bag? Do you think these are independent events or dependent events? Dependent. And the reason they're dependent is because we aren't starting with the same marbles in the bag every time. All right? If we drew it out, looked at it, and put it back, we're starting with those same 12 marbles every time, then those would be independent events. But because what we have in the marble bag is changing, these are dependent. The result here is dependent upon each draw. Okay, so this turns out to be a permutation. This is, we're not doing probabilities with permutations. That's just really advanced. But I could do it. This is, there are 5 blues, and we would pick out 3 of them. and there are 12 marbles in the bag, and we would pick out 3 of them. This is why we learned those counting techniques, permutations, and combinations. Because when we calculate probabilities, those methods of counting, whether it's a permutation or combination, are ways to calculate probabilities. I don't care to get that advanced because that's pretty advanced. I much prefer thinking about probabilities in a context. So I like thinking about it like this. We can multiply these fractions together, and we would just multiply straight across. So 5 times 4 times 3 is 60. And 12 times 11 times 10 is 1320. And so we have 60 divided by 1320. And they want the exact, in this particular case, the exact answer. So we're going to math frac it, and it turns to 1 out of 22. That is the exact probability. But you do need to read carefully. They do round it to the nearest thousandth. So to the nearest thousandth would be 0.045. Or they might say to the nearest tenth of a percent. So we would multiply it by 100, yeah, and so that would be 4.5%. Okay. So pay attention to the reading. Again, that is a big part of how you get Delta Math right or wrong, is whether or not you read what to round to, okay? So please read carefully. Any questions on this one? And of course, we're drawing 3 marbles, but sometimes you're going to be drawing 2, sometimes only 1, sometimes 3, sometimes 4. So pay attention to how many marbles you're drawing out, but you can set it up just this way. It's very, very fun. All right, again, example 2, determining, write the title, determining independent or dependent events. And again, you don't need these words, but this stuff, well, really this part here, and then we'll do the math to fill out the rest. This is exactly what you're going to see in Delta Math. I just took like a screenshot. A group of students at a high school took a standardized test. The number of students who passed or failed the exam is broken down by gender in the following table. And so you can see these tables we're getting pretty familiar with. Passed and not passed, male and not male. Okay. And we want to determine whether gender and passing the test are independent by completing the information. And so what we wrote on the first slide, there are 2 ways to determine independence. And so this is going to help us figure that out kind of nicely. We're going to complete the blanks and find the probabilities to the nearest thousandth. So first, ladies and gentlemen, how many students? Oh, let me give you a minute to copy down the table. And you don't necessarily need all these blanks. We'll do all the math necessary next to the table. So draw the table, and we'll do the math together. Draw that table. Okay. In this table, how many students took this standardized test? $240. Very good. So there are 240 students, and we got that by adding, of course, all these exclusive groups together. Okay. And so the first thing it's asking us to do is find the probability that a student passed given that they were female. Find the probability that a student passed given that they were female. Now, this is what we did yesterday. It is known, or the only group that we're interested in are the females. So, ladies and gentlemen, how many females took this standardized test? How many? Oh, I added up the wrong things. Of course I did. 102, yes. So here are our 102 females, 85 plus 17. 102 ladies took the test. And how many of those passed? 85. All right. So 85 out of 102 females passed. And so that is rounded to the nearest thousand. So let's see, 85 out of 102 would be 0.833. I'm going to use approximately because it is an approximation. Okay, and then we also need to figure out, so that's what I would put here. That decimal would go here in this box. We also want to figure out the probability that any student passes the test. Now, this is not just looking at females or just looking at males. This is the probability that a student passes. All right, so how many students passed the test? How many? 200. So that would be, here's all the students who passed the test. 115 plus 85 is 200. Good. Out of how many students? Out of the total 240 students. Okay. All right, that's a nice exact thing, not reduced, but so divided by 240, and we get 0.833. All right. Look, they match. The two results are equal. And if they're equal, the events are independent. And that's it. That's all we have to do, which is super nice. Okay. So the math is pretty easy. It's combining all the different ways we can figure out probabilities. Okay. So being female made no difference to pass the test. It didn't do differently than the males, which is good. All right, let's try one more of these, so just so you can see a slight difference. Same idea, slightly different way to calculate it. Again, on that first slide, there were two ways that we can determine independence. And so this is the and rather than the given. All right. So a group of students took a standardized test. A number of students who passed or failed the exam is broken down by gender in the following table. So we want to determine whether gender and passing the test are independent by filling in the blanks. Rounding to the nearest thousandth. So again, similar sort of table. Again, just the table is the important part, and then we'll do the math together. All right, again, how many students are taking the test? Uh-huh, 240 students. And again, that's just adding all those little groups together. Okay. And the first thing it's asking us to do is actually multiply two probabilities together. It's saying find the probability that a student is male, and we want to multiply that to the probability that a student passes the test. So let's look first at the probability that a student is male. So ladies and gentlemen, how many males took the test? 116? 115? Oh, 165. Oh, plus 84. Okay, so I'm going to add the males together and get 165. Thank you very much. There are 165 males that took the test out of 240 students. Good. And I'm going to put parentheses around that because I'm just going to type them into my calculator nicely. And I found that my Casio didn't do it correctly if I didn't use parentheses, so pay attention. All right, so, and then we also need to figure out the probability that a student passes. So how many students pass the test? 151. So here's all the students that pass. That's 151 out of 240 students. And I'm going to multiply those together. So 165 divided by 240 times 151 divided by 240. And I get 0.4325. What should I do? Round up. 0.433. All right. I had to round up on that one. All right. Now, the second thing we have to figure out is the probability that a student is male and they passed. So this is an and. So how many students were male and passed the test? 81 were male and passed the test out of how many students? 240. All right, so let's see. 81 out of 240 is 0.338, rounding up again. Okay. All right, these two results are different or unequal. They use the word unequal. I prefer different. Different, unequal, which means dependent. Different, dependent. I liked how that alliteration there, that was helpful for me when I was doing this. If they're different answers, then it's a dependent event. All right, ladies and gentlemen, that's all we're doing today. It's kind of an easy day. A little bit of review of combinations and permutations too. So have at that homework in Delta Math, and also feel free to, I encourage you to get started on your review, of course. Writing down what would be helpful for you on test day on Friday.